SpaceX's Starship is a sight to behold. This towering spacecraft, standing nearly 400 feet tall when paired with its super-heavy booster, is designed to be fully reusable. It represents a radical departure from traditional rockets. Its sleek, stainless steel body is devoid of the usual appendages, including landing legs. The current design relies on a daring concept, catching the returning booster and Starship upper stage with the massive arms of the launch tower, nicknamed Mechazilla. This approach, while innovative, presents both opportunities and challenges for SpaceX. The company's engineers have poured countless hours into perfecting this system, aiming for a future where starships land vertically back on Earth, ready for rapid reuse. The absence of landing legs contributes to Starship's streamlined profile, reducing drag during atmospheric ascent and descent. This design choice allows for a larger payload capacity and potentially lower development costs. However, it also limits landing options, necessitating a specialized launch and recovery system like Mechazilla. The success of Starship hinges on the reliability and efficiency of this unique catching mechanism. While the world watches with bated breath, SpaceX continues to push the boundaries of spaceflight engineering, aiming to make Starship the workhorse of future space exploration. Mechazilla is more than just a catchy name, it's a testament to SpaceX's engineering audacity. This colossal structure is designed to catch a returning Starship booster or upper stage with its giant arms. It's a complex ballet of timing, precision, and immense force. The system utilizes a set of hydraulic arms equipped with a grappling mechanism. As the Starship descends towards the launch tower, Mechazilla's arms reach out to capture and secure the vehicle. This method eliminates the need for the spacecraft to carry heavy landing legs, maximizing its payload capacity. The advantages of Mechazilla are numerous. It allows for rapid reusability, potentially enabling multiple launches and landings within a short time frame. It also reduces the risk of landing mishaps associated with autonomous touchdowns on uneven terrain. However, the system is not without its challenges. The precision required to catch a supersonic Starship is immense, and any miscalculation could result in a catastrophic failure. Additionally, Mechazilla is a complex and expensive piece of infrastructure, potentially limiting launch locations to those equipped with such a system. While Mechazilla might be suitable for Earth-based launches and landings, the vastness of space demands more versatile solutions. For missions to the Moon, Mars, and beyond, landing legs are not just an option, they're a necessity. The lunar surface, for instance, is pockmarked with craters and strewn with boulders. Landing a spacecraft safely in such an environment requires stability and adaptability that Mechazilla cannot provide. Similarly, Mars presents its own set of challenges, with vast plains of dust and rock formations that necessitate a robust landing system. Landing legs offer a simple yet effective solution. They provide a stable base for the spacecraft to touch down on uneven terrain, distributing the weight evenly and preventing toppling. Moreover, legs offer flexibility in landing site selection, eliminating the need for perfectly flat surfaces. For missions to other celestial bodies, especially those without a substantial atmosphere for aerobraking, Starship's landing legs would be crucial for safe touchdowns. They would be the critical link between a successful mission and a safe return of valuable scientific data and human explorers. Section 4, the Balancing Act, Trade-offs of landing legs. The decision to include landing legs in Starship's design really comes with a series of trade-offs. While landing legs provide undeniable advantages for planetary landings and enhance mission flexibility, they also bring along some complexities and challenges. One of the biggest concerns is, well, the added weight. Landing legs, especially ones that are robust enough to handle the intense stresses of lunar or Martian landings, can be pretty heavy. And this extra weight, it directly reduces the payload capacity, which could limit the amount of scientific equipment or supplies Starship can carry. Now on top of that, designing and integrating these landing legs into Starship's existing architecture is no small feat. The legs need to deploy reliably during descent, absorb the shock of landing, and endure extreme temperatures and even corrosive environments. It's a tough balancing act that requires careful consideration and some seriously innovative engineering. SpaceX engineers are constantly working on evaluating different designs, materials, and deployment mechanisms, all aimed at minimizing weight while maximizing strength and reliability. Section 5. SpaceX versus the world, a league of its own. In the world of space exploration, SpaceX, well, it just stands apart. Their relentless pursuit of reusability and bold engineering choices have propelled the company to the forefront of the industry. While competitors are still figuring out partially reusable systems, SpaceX is already landing and reflying their Falcon 9 boosters. And then there's Starship. Its development and potential dual landing capabilities only further cement SpaceX's leadership. No other company out there has even attempted to catch a rocket with a launch tower, or design a spacecraft capable of landing on another planet and then returning to Earth. It's honestly unprecedented. Meanwhile, SpaceX's rivals like Blue Origin and United Launch Alliance are still in the early phases of developing their heavy-lift rockets. These companies are sticking to more traditional approaches, focusing on expendable or partially reusable designs. But SpaceX, their innovative spirit and willingness to take risks, it's allowed them to leapfrog the competition, and their focus on vertical integration, from engine design to launch operations, gives them a significant edge in terms of both cost and development speed. Section 6.2 is better than 1. The power of dual recovery. By pursuing both the Mechazilla system and landing legs, SpaceX is, well, hedging its bets and maximizing its operational flexibility. This dual approach gives the company options, letting them tailor their landing method to the specific mission profile and environmental conditions. For Earth-based launches, where quick turnaround time is critical, Mechazilla is the fastest path to reusability. Catching the booster or Starship upper stage immediately after landing, it eliminates the need for transport and refurbishment, potentially enabling multiple launches in a single day. But then, for missions beyond Earth, or those that require landings on uneven terrain, landing legs are absolutely essential. Being able to touch down safely on all kinds of surfaces opens up a wider range of landing sites and increases the chances of mission success. This dual approach also adds redundancy. If one system runs into technical issues, or if weather conditions make a particular landing method tricky, SpaceX has the flexibility to switch to the alternative. And that flexibility, it's crucial for ensuring mission success and keeping delays to a minimum. Section 7, Starship's legs, a giant leap for spaceflight. The potential return of landing legs to Starship, honestly, marks a pivotal moment in the history of spaceflight. It represents a shift towards a future where spacecraft are designed not just for single-use missions, but for routine travel and exploration beyond Earth. These landing legs, once thought of as relics from the Apollo era, are now at the cutting edge of SpaceX's ambitions. They stand as a symbol of the company's commitment to pushing the boundaries of what's possible, and their unshakable belief in a future where humanity has a permanent presence on other worlds. Successfully developing and implementing landing legs on Starship would have massive implications. It would pave the way for sustained lunar and Martian exploration, enabling the construction of permanent outposts, and eventually, the colonization of other planets. SpaceX's relentless drive for innovation isn't just about building bigger rockets, it's about making spaceflight more accessible, more affordable, and ultimately, more routine. The return of landing legs to Starship is a testament to this vision, and a giant leap towards a future where humanity becomes a truly multi-planetary species.